Okay, there's two trig identities we need to work with in A1 maths, and the first one is that tan theta equals sine theta over cos theta. An identity is true for all theta. The only exception to this is where tan theta is undefined. So, for instance, cos 90 is 0, so tan theta is undefined when theta is equal to 90. But where it exists, it's true for all theta, and we proved that from the unit circle. So the sort of way we'll be using this trig identity is to solve equations. So we can solve for sine theta equals cos theta for 0 less than or equal to theta less than or equal to 360 degrees. So at the moment we can't solve this because it has a sine theta and a cos theta in it, but I can divide right through by cos theta, and that will give me 4 lots of sine theta over cos theta equals cos theta over cos theta. You probably don't need to write that line in, to be honest. And so 4 tan theta is equal to 1, and tan theta equals a quarter. And then this is just like the ones you were doing earlier. So you do shift tan of a quarter. That gives you theta equals 14.0. And then on the tan curve, you don't really need to work with the sketch, because if you think about what happens with tan, it just repeats every 180 degrees. So to find the next solution along, you can just add 180. So there's one at 14 and one at 194.0. So 2 solutions to that trig equation. I also want to show you one that looks like it will use the tan identity, but it actually doesn't. So it's probably a good place to see it while we're here. So for example, solve 2 sine theta cos theta equals cos theta. So it's tempting to think, okay, that looks like a tan one, so I'll divide right through by cos theta. But that would just give you 2 sine theta equals 1. I'm not sure this is quite doing what I want it to. I'm going to change that to a sine theta, sorry. There. And we'll go 0 to 360. So it looks like tan, so it looks like you can divide through by cos to get tan, similar to the one on the other side of the board. But if I divide this by cos theta, I'll get 2 sine theta equals tan theta. And so we know further forwards we've still got 2 trig identities in one equation. And the other thing you've got to be careful of is it's really tempting to divide both sides by sine theta to get 2 cos theta is equal to 1. And you can't do that either, because you lose the solution that sine theta could equal 0. Similar to this scenario, if you had 2x squared equals x and you divide both sides by x to get 2x equals 1, you lose the solution that x equals 0. So instead you have to subtract x, take x out as a factor, and then x equals 0 or x equals a half. So you mustn't divide by variables unless you know they can't be 0 or you'll lose that solution. So I need to instead take away sine theta. And then take sine theta out as a factor. And then we've got two things multiplying to 0. So sine theta equals 0 or 2 cos theta minus 1 equals 0. And then if sine theta equals 0, I always think zeros, ones and minus ones, you can just look at the curve really. We're going between 0 and 360. So sine is 0 at 0, 180, 360. And then this one here gives us that cos theta is equal to a half. So shift cos a half gives you theta equals 60 degrees. And then going into this cos curve, there's 90, there's 270, 360. So we're going forward 60, back 60 for cos. So theta equals 60 or theta equals 300 degrees. So there's actually 5 solutions to this equation. So don't be tempted to divide through by sine. Instead, you need to take the sine away, pull it out as a factor, because sine theta equals 0 is a valid solution to that equation. But the ones you see more of are these ones here. So here I can divide by cos to get 4 tan theta as well. And it's okay to divide by cos because cos theta cannot equal 0, because that's where tan is undefined. So 4 tan theta is 1, tan theta is a quarter, and you get your 2 solutions. So I'm hoping this will work. If it doesn't, you have to tell me. But there's some questions for you with some answers. So if you could work through those, that shouldn't take too long. They're mostly tan ones. And there's some answers there. So I thought you could pause your YouTube and work through those. And if that hasn't worked for some reason, just tell me and I'll set you some book questions next time. Okay, thanks.